Woodard here. I just wanted to put together a quick video. You guys had expressed some concerns and some questions over your worksheets, so I'm going to answer those real quickly. Hey, just so you guys know, Monday went really well. I am recording your screens during our entire pre-algebra session, so I get a report produced back at the end of that, and it just says where you spent all your time. Throughout the session, I also have notified after 1 minute of inactivity. So if you sit there longer than a minute, I get a notification, a flag that comes up and says you've been stalled. That lets me know if you need help. So please don't just like pull up my video and leave it on pause. That's not going to work. I need to see you guys working your way through the video and then progressing on into the worksheets and utilizing your tools to get a hold of me if you have any questions. Hey, that Google form worked really well. Thank you so very much for doing that so that we could, I knew exactly like where you felt comfortable and where you felt confident and where you didn't. Hey, so I'm going to go over real quickly worksheet 1-2. Worksheet 1-2 looks like we had a couple questions. And so if you're looking at this, this will help you guys with those problems on that worksheet. Hey, just wanted to talk to you guys real quickly about the way we classify numbers. So just to begin with, you guys probably remember when you were in kindergarten, you were learning to count. Your teacher was showing you guys like counting like 1, 2, 3, and then you kept going 4, 5, 6, 7, 8. You guys just kept counting, and you were counting whole numbers, and you started with the number 1. Those are called, that set of numbers is called our natural numbers. So anytime you see a number that is like a 1, 2, 3, 4, 5, 6, 7, like a counting number, that falls into this set in math called the natural numbers. All right. Then we discovered and came across a value for when we have absolutely nothing. So 0 got added to the set. So we have 0, 1, 2, 3, and it just keeps going on like our counting numbers. When we add 0 into the set of numbers, this becomes our set of whole numbers. Now, what I want you guys to notice is that every natural number is a whole number. Every one of these belongs to this set. The only one that is not a natural number in the whole number set is 0. All right, then we discovered that we also have numbers that represent negative values. So we have numbers, we still have our 0, our 1, our 2, our 3, our entire whole number set, but we started to also work with values of -1, -2, -3, and so on. That set of numbers is called integers. Integers include the negative values. So they have the 0, they have the 1, 2, 3, as well as the negative numbers on the other side. All right, and then we became more familiar with numbers that lie in between numbers. So when you think of like the number 1 and 2, we have like 1.5 that sits like smack dab right in the middle. So we have all of these bits and pieces, these parts. So think of all the decimals and all of the fractions. So we have everything that's in the integer list, the 1, the 2, the 3, but we may also have in here 3.5, 4.5, 6.5, 7.25. We also may have on the other side negative numbers. We would have like our -1 or -2 or -3, but we may also have negative 4.2. We might also have fractions in here too. So this would include, so this set includes decimals and fractions. So all of those little bits and pieces that lie in between all of the whole numbers. This set of numbers is called our rational set. So we have a rational set of numbers. So we have rationals, integers, wholes, and naturals. And what I want you guys to notice is like, look at some of these repeat, like the number 1. The number 1's in all of those lists. So if I asked you on the worksheet to tell me, it says write all the names that apply to each number. If I was given the number 1 is a natural number, a whole number, integer, and a rational number. It includes this rational set. Okay, now my Nearpod video talked also about another set of numbers. It talked about this other set of numbers that is includes some kind of different, when you think about like numbers that don't really make a whole lot of sense. So I want you guys to think about this number like, that's in blue. I'm going to switch so the colors don't match. So I'm going to go to a green. Now the green, if I think about this number pi, Now, pi is pi is just a value for how the diameter of a circle relates to its circumference all the way around. So when you think about a diameter and then you go circumference all the way around, the relationship is pi. Pi is approximately, we don't even have like an exact value for it. It's got that 3, you guys have probably seen this, 3.14159, bloop, 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 bloop. It keeps going and going and going. Nothing repeats. It makes absolutely no sense. There's no repeating and it does not ever end. This is an odd number. I also want you guys to think about when I talk to you guys about square roots. So I also talked to you guys about something like last week when I talked to you guys about taking a square root of like 4. What I want you guys to do is square root of 4 is think of some number when you multiply it by itself. What gives you what number does that equals 4? There's only one number. 2 times 2 equals 4. So the square root of 4 is going to be 2. Right? So you guys, I talked a little bit about square roots and I talked about squaring those. But I want you to think about this one. If I took and I wanted to do the square root of -4, so what I'm thinking about there is what number do I multiply by itself to get a -4? I don't know if you guys remember working with integers, but when you worked with integers, we learned that a positive times a positive is always a positive. And I hope that you remembered that a negative times a negative is still a positive. So the only way to get a negative number here is if one's positive and one's negative. How in the world are you ever going to get a value for the square root of -4? The square root of -4 actually works in a set of numbers called imaginary numbers, and we're not going to get into that. That's higher math. But I want you guys to look at both of these numbers and recognize that pi and recognize that the square root of -4 are very weird numbers. They don't work out to be a nice even number that would fall into any of these other sets. That is going to be considered irrational. So those are my irrational numbers. So I have irrational and all the rest of these are rational. Every single one of these, every single set, both the irrational and the rational, all the integers and the wholes and the naturals, they all lie within the real number system. So every single number that you could possibly think of should be real. So when you look at your worksheet and you're looking at numbers 1 through 8, you can absolutely tell me every single one of those is a real number. They all fall into the real category. Some will only be real and irrational. Some will be real and rational, integer, whole, and natural, like the number 1. Number 1 falls into all of the categories except for it being irrational. So you'll have multiple answers for some of your questions. So now that we've gone through those different sets, I want to specifically take a look at some of the questions that you guys asked me. You put on that Google form a couple that you were like, whoa. Hey, and one of you guys actually asked me how you do a square root symbol in Class Kick. We don't have symbols in there. So if you could just either type out square root or you could hand draw it with a pen. Hand draw it with a pen and that. I'll get it. I'll know what you're going for. Just do the best you can do with all of that. Okay, so I want to take a look at a couple off of this worksheet. One of the questions was number 6. Number 6 said negative square root of 100. Okay, now I want you to notice that that negative sign's outside of the square root. It is not underneath the square root. So we're not talking about something that is imaginary or irrational here. Irrational would have that negative on the inside because you can't get a negative solution when you multiply a number times itself. You're always going to get a positive solution. So since this is, look at just this side, this square root of 100, you're thinking to yourself a number times a number equals 100, right? That number times itself, I'm hoping you guys would come up with 10. So the square root of 100 is just 10. And if I brought down that negative sign, I'm looking at a value here. This value of this number is negative 10. It's the exact same thing. This and this, they're equal to each other. So when you look at this and you look at like how to classify that, I would know that this is not a counting number. We didn't learn negative numbers in kindergarten. We just went 1, 2, 3, so it's not natural. This is not 0, 1, 2, 3, 4, 5, so it's not going to be the whole numbers. Now I'm going to bump up. We include the negative numbers, right? So when I included those negative numbers in there on both sides of the number, when you're thinking about the positive side of the number line and then 0 and then the negative side, negative 10 is going to be on the negative side. So it would fall as an integer. Okay, remember, I don't want to just stop there because I also want to think about, okay, now integers open themselves up to the rational numbers. The rational numbers include all of the integers plus all the parts. So since this is still can be written, it can still be written as a fraction, just simply write it over 1. This is going to be considered rational as well. So it would fall under the rational set. After that, we're going to umbrella it all over the real number system. So you should answer every single problem. Numbers 1 through 8, every single one of those should have a real number solution. They're all real. There isn't anything you guys aren't working in the imaginary set. We're not in that math quite yet. You guys will be getting there if you guys keep advancing with your math. So that's number 6. And like I said, that square root symbol, if you're struggling with that, just do the best you can with that tool in Class Kick, pen tool, and I will get it. I promise I can figure out your guys' solutions. I don't know if there's any others that you guys specifically asked me for. I can maybe take a look at number 2. Number 2 is the square root of 36. I would do the exact same thing here. I would think a number times a number that equals 36. I would hope that you guys would find 6 times 6 equals 36. So the square root of 36 is the exact same thing as 6. So I want you to think about that number 6 and think, okay, is it a counting number? 1, 2, 3, 4, 5, 6. It is. It's a counting number. And since it's a counting number, we should be able to classify this value, this value as a whole number. It's as also like we're thinking just because I added 0 in here, 6 is still part of all of that. So it's going to be, it's going to be natural. Sorry. Naturals are counting numbers. Wholes, adding the 0 in. It's also an integer. It's also rational. And it also is part of the real list. This one falls into a lot of categories. This one meets all kinds of ways we can classify that value, the square root of 36. Let me know if you guys have any other questions about any of this. This is just a lot of classifications. We're still not doing any real like math computations quite yet. I'm here to help though if you guys have any questions. Hey, and I know that we're also going to be doing NWEA testing. Your attendance is super important. So remember, I'm keeping attendance on Google Classroom. And I'm also keeping attendance through GoGuardian. Please make sure that you guys are showing up. I'm getting the training for the remote end of NWEA testing tomorrow. And then I'll be gearing up and getting prepared to start issuing those tests out to you guys at testing time. And during that testing time, we'll all have to meet and we're going to work on our math exam. So expect that to be coming up very soon. I'm happy to help with any other questions that you guys might have. So just give me a quick email and I'll be in touch. I hope you guys all have a great day. Thank you so very much. And I'll be available to answer questions tomorrow from 10 to 11 as well. So if you feel like you have anything, that is my office hour. So you're welcome to pop on in and visit with me and we'll get something squared away. I might push out a Zoom session for that. I don't know. I got to think on that. So don't hold me to that one. We might just have to do a little bit of emailing back and forth until I get my kind of my bearings with everything. So thank you guys so very much. Don't hesitate if you guys have any questions. Have a great day. Bye.